Timers, the wonderful world of timers. All right, so there are 3 different types of timers. What are they? Top of your heads. On delay, off delay,
Pulse.
retentive. I'm not worried about pulse. All right, on delay, off delay, retentive. Those are the 3 types of timers that truly you'll probably see in industry. And truthfully, of those 3, you're only going to see 2 of them. Most of the time, you're going to see on delay and you're going to see retentive. The off delay does exist. There is a purpose for that. And the best example I have is like an oil pump for a machine. You want the oil pump to run a few seconds longer than the machine does, so the machine is completely shut down before you starve it of oil. So an off delay has a perfect use case for that. But in the long run, I don't see a lot of off delays. And a lot of the programming we'll do, I try to get you guys to use off delays, but some of you guys figure out ways around that. You can normally use an on delay if you're tricky enough. So, to each their own. All right. So first, I like to believe I've already pointed this out to you guys. And actually, I guess I should keep Epic Pen up because why not? It'll let me draw random things on the screen. Up here, and I really don't like the black color. Let's go back to pink. Pink stands out a bit more. Up there, you can see, there we go, even thicker. Basic instructions. All right. So far you guys have all probably just been using these up here. All right. What's up there in that top left, which I'm sorry is so stinking small for you guys, is the favorites. So you can put whatever you want there and normally it will stay. Now remember, on your computers in front of you, there's deep freeze, so it will not stay. All right. So not going to work, unluckily. However, normally you could put whatever things you want on the top and they will stay there for you. So something to think about. But anyway, over on the right-hand side, you have your bit logic, which is your makes and your breaks and your coils and your sets and your resets and those types of things. And then if we go down, we have timer operations. So you have ton, TOF, and ton-R. All right, ton, time on, TOF, time off, ton-R, time on, retentative. All right. So we can cheat this. You don't have to actually come over here to the right to get your timers installed. All right. We can cheat this. Oops, wrong button. By using the little mystery box up there. And if I go ahead and drag it down, you see I've got a little question mark and it says in and out. And it's like, okay, now what the hell do I want to do? So if we actually double click on the question marks, we can type. So if we want an on delay, you would type ton. And notice it does auto sort everything. So it's like, oh, these are all the function blocks that start with a T. What do you want? And you're like, there, TO gets you all 3 timers that are important. So we're going to go ahead and do a ton. You're going to hit enter again, and a window will pop up. Let me get Epic Pen out of the way. That looks like a good place for it. Now, this is asking you for a name, and what we are doing is we're creating a data block. All right. What this is it's taking a bunch of different variable names. It's going to create them all for you at once and store them all in one nice little block. So instead of you having to go through and create your enable and your timer timing and your done, it's going to do all that for you, because it's also going to create your elapsed time and your preset time and I think one other variable, but nothing that we're worried about this moment. So it goes through and creates all of those for you. So it asks for a name. Do you have to give it a name? No, you can just leave it as it says IEC timer 0_DB for database. All right. I'm going to call this timer 1, or, timer 1 on. I'll delay to it because, as I've told you guys before, take the extra second to type out more information because you're going to regret it later. All right. So as you can see, we now have timer 1 on delay there. It gives us our name. We have an in, we have a Q, we have a PT, and we have an ET. All right. Now, this is where it gets kind of fun. So let me go ahead and throw that there. And I just created a whole bunch of variables, tags, switch 1 through 6, it seems. All right. So I have a switch in front of my timer, so I have something to enable my timer. All right. I have that going to in. All right. Now, unluckily, or luckily, however you want to look at this, every company does their timers differently, as you probably noticed in the book. All right. Right? Alan Bradley had this like nice box that you filled in that had your 4 different fields just right there for you. Siemens does it like this. The other ones, there was just like a circle, and you had to expect it to fill information in somewhere else. It kind of just starts to drive you nuts. All right. So you'll find one that you like, and luckily that probably won't be in the software your company uses. So you'll find one that you have to deal with. All right. Anyway, what is PT?
Preset time.
Preset time. So what does preset time mean?
Time you have your timer set.
Right. How long do you want your timer to count for? All right. Now, again, in Siemens world, we actually give it a unit. All right. In Allen Bradley world, you get what's called a base for that. So you would have a base of 1,000 or 0.001, I think it is, which means that there are 1,000 counts per second is what the base is telling you. Is how many counts per second. So in Allen Bradley world, if you want to count for 5,000 with a base of 001, you actually need to type in 5,000. All right. In Siemens world, we can type in what we want. So you could type in 5S and hit enter. And notice that it automatically puts T pound 5S. All right. So it's formatting this as a different data type, as a time data type. All right. We could also type in 5,000 milliseconds, MS, and it would accept that as well. All right. So it is overall on the smart side. So you can do milliseconds, you can do seconds, you could do hours. I don't know if you can do days. It probably is a, yep, 1D for day. So you could do days. That'd be kind of a crazy one. But anyway, it is possible. We're going to stick with 5 seconds. What is ET? What? Elapsed time. All right, now you will notice that doesn't have any red question marks in it. All right, if I delete this one, I have red question marks there. All right, notice that one doesn't have any red question marks. So red question marks mean you must fill in this field. All right, no red question marks means you don't have to fill it in. So we can actually leave the elapsed time empty. So let me go ahead and download this. This will probably take a second because this will be, I think this is the first time I'm downloading to this since I did my little reset earlier. So there's nothing on this PLC. All right. So OnDelay is what we're starting with. Let me go ahead and start this up. Finish. All right. We've got my green light. Let me go ahead and put our sunglasses on. So here we are in our live preview, as we've shown you guys before. So you can see switch 1 not activated. At the top, T pound 0 MS, so we have no time elapsed. All right, so in Siemens PLCs, it tells you how long the counter is by being right above it. It tells you how many milliseconds has elapsed. All right, and then we have our preset and we have our elapsed, which is still empty. Now, my favorite thing about this, if I remember correctly, once I flip my switch on, anything happening? Should anything be happening?
Elapsed time.
Right, that time at the top should be counting right now. This is one of the things about Siemens that drives me bonkers. Unless you reference your timer as an input somewhere or use it somehow, it will not count. Right, like there's no reason my timer should not be counting right now as far as I'm concerned. Yeah, it may be wasting memory because I'm not using it. I don't care. I put it in my damn program. You should be counting. All right. However, it does not. So we have to go ahead and give it some sort of output. Now I'm going to do this in 2 different ways just to prove something to you guys. So first, you can, if you just want your timer to directly control something, you can just throw it right after it. All right. And that is what the Q is. The Q is the equivalent of the Allen Bradley done, DN. All right. So your timer Q will become true when the timer is done counting. All right. However, how I actually prefer you guys do this is to actually reference your timer and go with the Q bit like that. All right, let me go ahead and download that. Both of those rungs mean the exact same thing other than the fact that it's 2 different outputs. All right, that's the only difference between them. Is I have output 1 on one rung and output 2 on one. on different rung because you can't use the same output on multiple rungs. All right. So here you can see they're both true because my switch is still flipped. As soon, with a OnDelay timer, as soon as that rung loses power, in this case, one switch goes false, that timer goes back to nothing. All right, so it's a big fat 0 milliseconds now. When I flip this up, you'll see at the top we start counting. It looks like we're counting in roughly 300 millisecond increments on the screen. That tells you how fast the computer is actually updating. Roughly 300 to 400 milliseconds, just so you guys know. So about 2 to 3 times per second, it is your computer is updating. So that's always nice to know. So you can see everything is exactly the same. Once our timer hits 5 seconds, that Q bit becomes true, which turns both of our outputs on. All right, so nothing too fancy about that in the long run. I personally hate having my timer in the middle of the rung. Now, this may come because the first thing I programmed was Allen Bradley, and you couldn't do this in Allen Bradley. So by doing this in Siemens, it just bothers me. Also, I think if you follow my advice and you do it as a separate rung, it will make it easier to read for someone who hasn't used Siemens before. Because they won't be like, they'll be like, what the hell's this thing after the timer? Like, why is that not turning on right away? Because in Allen Bradley, if you do that, if you put an output right after your timer, it's just like the enable bit. As soon as the timer has power, it turns on. So I truly think that's why I don't like it, is because I started with Allen Bradley, not Siemens. So I was never taught to do this, and it bothers me. But to each their own. Now, one other thing you will notice, which this will be kind of hard for you guys to see probably. Maybe not. Maybe it'll be big enough. Can you guys see the screen? It's kind of small. What are our options for that OnDelay?
IN, Q.
IN and Q. So IN equals what? Input or enable. All right. And Q is output or done. All right. What are we missing?
Reset.
Nope. Your TT, your timer timing. Siemens just gives you the finger, like not an option. And actually, it's even worse than that. It is even worse than that. Hold on, let me go ahead and put an in there just for good measure. All right, let me go ahead and download this again. So, Siemens does not give you the option for a TT, which I do not understand at all. It's like, how hard is it for you to like flip a little button and make a TT in your program without me having to create it myself? And the reason I say it is even worse, oh, sorry, I have to go here, is because if I actually come in and look at my tags, which I'm sorry I can't make bigger, but you will notice there is an RU, or running, that works just like a TT. I'm like, it's there. It exists. And if I flip this, you'll see running is true right now. We're at 3 seconds, 4 seconds, 5, there, and it's off. I'm like, it exists. It's right there. I can see it. I can watch it. But they're like, screw you. You can't use it in your program. All right. Which means, unluckily, that you have to create it yourself if you want to use it. It's not that bad to create, all right, but you do have to create it. Now, you could create it once and always reference it using a memory bit. All right, so let's go ahead and just do that for fun. And I need a memory bit for that, so let me go ahead and quick make a tag. Timer 1 TT. Or should I call it RU now? We're going to stick with TT to give them the finger even more. All right. So basically, we want this to be timer 1 on. In is true, but we're not done. That is a timer timing right there. All right. You guys will use that probably more often than you want. Which is why I said if you want to make it like this with a memory bit, and then you can just always reference that one memory bit whenever you're dealing with your timer, you can do that. However, if you just want to reference or make it every time you want to use it, you can do that as well. All right. So here you can see, let me go ahead and reset this. So once I go ahead and start this, you'll see my timer1TT memory bit there is going to go true. All right. And then after 5 seconds, it will go false. So we're true. And once our time elapses, we will go false. All right. So I now have created my own timer timing because Siemens is not going to give it to us. So you have to create it yourself. All right. So OnDelay timer, and I guess we should have hit this up from the beginning. OnDelay is as soon as the timer gets power, that block, that ton block, as soon as that gets power, the elapsed time has to pass before the output becomes true. All right. So to me, it's the one that makes the most sense. It's there is an on delay. So the timer gets power, but before the output is true, there is a delay before it will turn on. So it's timer on delay. So there's or timer delay on. All right. You want to go that way. But anyway, there's whatever that timer second is. Now the other option, all right, is a retentative timer. That's the other one that I want to talk about today. Come on, go offline. Here we go. Let me just go ahead and change this to a ton-R. All right, and you will notice something. We have another field on our timer block. What is it? R. What does R stand for? It's probably what you think. What? All right, it's not what you think. Not relay.
It's reset.
It's reset. All right. So, what's the difference between a retentive timer and a traditional on-delay timer?
Reset it after a certain amount of time.
No, I mean you could overall do that to an on-delay if you wanted to. You could reset. I mean, by taking power off of it, you will reset it. So if I just had normal on-delay for a minute and I flip the switch on for 30 seconds and then I flip it off, it will forget and it'll reset. All right.
Retentative counts, right?
Counts what?
Cycles or?
Yeah, you're on the edge. What does the word retentive mean?
To keep, remember.
To keep to remember. All right. So what do you think that means if I take power away from a retentive timer? What do you think is going to happen?
It's going to remember that power was there.
It's going to remember that power was there and start counting again from where it counted to the first time. All right. So let's go ahead and download this. And give me my little sunglasses so we can see what's going on. All right, so now that this is going to turn green any second now. Oh, we're offline, or we're not in run mode. Is that our problem? There we go. So you can see we're already counting. We're at 2, we're at 3, we're at 4. As soon as I flip this back, notice that time stays. All right, that is the big difference between a retentive timer and a normal on-delay timer. All right, on-delay is great if you want to just so great example. Your company uses a crap load, a metric crap load. Let's go to actual terms here, right? Of compressed air. All right. So uses a lot of compressed air. Well, once your compressor gets too low, you start your motors back up to make more compressed air. Well, keyword there is motors. Well, if you start both motors at the same time, you brown out part of your facility because those 10 horsepower air compressor motors are just a little bit too ballsy to start at the exact same time. All right. So an on-delay timer you can use to say, we're going to start run. So once the pressure gets too low, start the air compressors, right? Well, we're going to start one, and 10 seconds or 20 seconds after we start the one, we're going to start the other one. All right. So that way we kind of off-shift that massive spike that they're both going to create. We're going to delay that second one so we don't have as big of a massive spike. All right. So that would be a great use for an on-delay timer. A retentive timer, a great use for it would be for keeping track of how long those compressor motors have actually run for, because you have to change the oil in them. All right. So every time that compressor runs, you'd flip, oh, compressor's running again. All right, our retentive one is counting. And it's counting, and it's like, okay, it's done running. Oh, it's running again. We use that much air. Our 20 horsepower compressor just run all the freaking time. All right, so we just keep counting and counting and counting. And then once we would get to a minute, which I am really not going to wait to get to a minute with this, then the output would turn true. All right, so it works just like an OnDelay. Everything is the same. The timer timing works, again, if the timer is counting, timer timing is enabled. All right, if the timer has power, in is on. All right, it doesn't matter if we've passed our 1 minute threshold. If we're at 5 minutes, or hours or days or whatever your oil change time frame is, you're at 5 days of runtime on those compressors, and that counter has power, or that timer has power, it is going to be true. All right, and if you have 5 days on there and you're only supposed to count to 1 day, well, it's going to be outputting a light saying, hey, this is true. It doesn't actually stop you. All right, so you can see that we made it to our minute mark because I've rambled enough to distract you all, and now our output is on. So it doesn't matter if I flip my on switch on or off, it still says, hey, we're at 1 minute. All right, notice even though in isn't true right now, Q is. That one may bother some of you. Even though the timer doesn't have power, the output has power because we've already reached our 1 minute timer, our preset time. All right, and then to reset it a retentive timer, we have to bring that R line positive. All right, so in this case, I have it set up to switch 2. As soon as I flip that, boom, everything goes back and we go back to 0. I can reset it at any point in time. All right, I could be like, okay, time to reset. Notice that in is still true, but we're resetting it right now, constantly. Every run of the code, we are resetting this. So it might be getting to like 1 millisecond before it gets reset. We're never going to see that on a screen again. All right, because I have that reset line stuck high. All right, so nice little bit there. Now, one thing you will notice is, or let's see if you notice. What do you notice about switch 2? I mean, overall, that's what I'm going for. Yeah, it doesn't have a what?
Output?
No.
There's no entry in the line other than there.
Right, it's just like coming from nowhere, all right? Which means we also look at it, we don't have a make or a break sign. All right? By default, it's set to a make, all right? And by default, we only can have one item controlling the reset. Now, that wouldn't be too hard. You could have a whole nother rung or network set up, so you have all of your logic on that run go into a memory bit to then reset the timer, all right, and just put your memory bit there. That would be fine. But if you don't feel like doing that, you can, let me go ahead and delete this. You can do a little branch off of this, do your logic, whatever it is, and then we can actually drag this to our reset line. And now it looks probably something more like what you want it to look like. All right, so it works just fine that way. You do have this as an option as well. I really want its own run for this one. All right, you have the RT in output, little square box, and that is a reset timer. All right, you don't have to just set a reset. You don't have to just set a retentive timer with this. You could reset a you could reset a non-retentive or an on-delay or an off-delay non-retentive. You can reset them with it. All right. One thing I haven't pointed out to you guys, and let's blow these things up real big. All right. Notice it says timer 1 on delay, which is the name of our timer, period in or period Q. All right. That is saying that basically timer 1 on delay is saying, hey, there's this data block that I want to access, and I want to access the one specific bit of that, the in or the Q. All right. So again, in an ideal world, we'd be able to access all of those, but we cannot. We can only access the ones that we have permission to access. And when it comes to bits, it is in or it is Q. If we were actually dealing with numbers, we could actually access the elapsed time or the preset time. All right, but we're not dealing with numbers. We're just dealing with bits in this class right now, at least. So in and Q. So you always have to have that dot something. Now the nice thing is, as soon as you type timer and you select it from that drop-down box, it automatically puts the period in for you and says, which bit do you want to use? And then allows you to select in or Q. So it does try to keep you from making a stupid mistake. If I click off of this right now, notice it goes red. And it's basically saying, I don't have enough information to do this correctly. All right. And because right now this is trying to reference the entire data block. So it's trying to reference all of these. So it's trying to reference 3 time values as well as 3 bit values. And we're dealing with a bit tag. So it's like, what am I trying to read here? So you do need to give it that final little piece of information of Q or in. All right. So questions on timers at this point in time? Oh, one other thing I want to point out. This one is fun. We can just do delete. Let's just get rid of this whole freaking network. All right, so we're gonna do this. Anyone know what this is called in the book?
Cascading.
It is excellent. Cascading Timers, which I'll be very interested to know if this is actually going to work as I have it. Why are there errors? Oh no, they expect me to have something ahead of this. It doesn't like that I don't have any input on there at all. Which, again, I have a problem with. If I want to write my code that stupidly, I should be allowed to write my code that stupidly. Well, you could reset the timer somewhere else, so you don't truly need anything in front of it. Like, it is not actually a requirement, but as far as they're concerned, it is. So what we have here is cascading timers. So what that means is timer 1 controls timer 2. Timer 2 controls timer 3. Why the hell would you want to do this? Couldn't I just make one timer that counts to 15 seconds instead of 3 that count to 5? Okay, good. You could, if you want to say, okay, output 1 will turn on at this point in time, output 2 at this point, output 3 at this point. That is a great option. Any other options or any other reasons?
What if your time limit, or what if the time you need is above an individual timer's limit?
Excellent. So we are dealing with computers here. They can only count to a maximum value. I don't remember what that value is in Siemens world. I think it's multiple days. So I don't think you'll normally run into this problem. But yes, overall, if you want to count to a number that your one timer physically can't count to, I believe in Alan Bradley world, that's 32 or 64, 6.4 million, 64 million thousand. I don't remember. It's freaking up there. It's really what it comes down to. All right. So yeah, if you have a timer that counts to something that's more than your one timer alone can count to, that is when you would do a cascading timer. All right. Or if you want to have some sort of series of events. So after 5 seconds, light A turns on. After 5 seconds again, light B turns on. After 5 seconds again, light C turns on. So you know how far in the progress of, melting a piece of plastic or whatever you're at. You can just go red light, yellow light, green light. All right, pull it out, put the next one in type of thing. That's another great option. So you can cascade timers. Again, this overall does work. All right. Having them just one in a line like that, not my favorite thing. Remember, I do highly prefer to have them all on their own rungs. I even actually overall suggest you guys do multiple networks instead of this rungs that I'm doing. The reason I'm doing rungs like this is because it's a little bit smaller on the screen, because I don't have to have it say network 1 and all this information again. And the reason I suggest you guys do multiple networks is because when it does have an error, like if I try to download this right now, it's going to have an issue because, again, I don't have inputs on those. Notice all this does is say network 1. Where if they were all on their own network, it would go, network 2 has the problem, and you would be able to quickly, a little bit quicker, find that problem. Where if you have 50 lines of code in network 1, all of a sudden you're like, well, which of the 50 is it? Anyway, so I would highly prefer, no, you're supposed to go there. And this one should be timer, oh, now IEC 1. Done. This one should be IEC 0. Fine, I will retype it. Done. All right, so there you go. We've got that all going on now, and this does the exact same thing. Now, here is where it gets a little trippy. Are we all ready for this? What happens if I do this? What the hell is going to happen if I run that code? Yep. So, in this loop, timer 0 controls 1, controller 1 controls 2, timer 2 controls 0. It's a kind of a little like, again, infinite loop. Basically, timer 0 will count to 5, then timer 1 will count to 5, then timer 2 will count to 5. At this point in time, timer 2 finishes counting, and it says, hey, timer 0, you lose power. Losing power on a non-retentive timer means it forgets that it counted. Well, so killing power to timer 1, or 0, 0 resets 1, 1 resets 2, 2 enables 1 at 0 again. So it's this infinite loop of what's happening. A little bit trippy in the long run to actually like see that happen. Let's go ahead and download it. So this will count from 0 to 15 seconds without any interaction from the human, and then it will reset again. All right. This is actually how you have to do it with only 2 counters instead of 3, or 2 timers instead of 3. In Siemens world, no, Allen Bradley world, if you want to have a blinking light. You have timer 1 control 2, and 2 controls 1. So as long as one timer is counting, you have the light on. When the other timer is counting, the light is off. That is how you now have to do it, as far as I know at least, in Allen Bradley world. Kind of annoying in the long run, but that's just the way the game goes. But yeah, as you can see, 0 has finished, 1 has finished, now 2 is finished. As soon as 2 is done counting, it will reset all 3, and then 0 starts to count again. Infinite loop of counting to 15. All right. I'll give you a hint. You're going to use this in the not too distant future. There's a reason I show this to you. All right. So, questions about OnDelay, traditional OnDelay, or retentative OnDelay? No? Not as zero zilch?
Not yet.
All right. Questions on making your own timer timing? So, timer timing, write this down. Make for in, break for done. That's all you need to know. Put those 2 in series. A normally open break make contact for the enable bit or the in bit, and a Q bit is a break or normally closed. All right. Those 2 together will make you a very nice timer timing, or as Siemens call them, running bit. All right. All right. So if we have no questions at this point, I will go ahead and stop the recording.